Section 10.2 is a section about triangles, and I think if you read the section, they have a very good explanation about what a triangle is. And I know that we understand that that's a three-sided object. It's got three interior angles. Those angles can take on many shapes and forms. But the first thing that is discussed, the first main thing after defining a triangle, is the measure of the angles. And again, your book gives a good explanation and a good proof for why this is. But we know that the sum of the angles in any triangle are going to be 180 degrees. So let's say that we have a triangle and we know that one angle is 83 degrees and another angle is 27 degrees, and we're trying to find that missing third angle over there. Well, if we know that the sum of the angles, maybe we'll call it x, is 180 degrees, then we can subtract to find the missing angle. Okay. So if we add up the 27 and the 83, we have 110. We know 110 plus our mystery angle is going to be 180. So then we find out that x is going to be 70 degrees. The angle that we are trying to find right here is 70 degrees. If you're given two of the three sides of a triangle, or not two of the three sides, two of the three angles, you should be able to find the third one. There also, if we're given something like this, where we know the angle, some of the angles, but we don't know all of them, 1, 2, and 3 maybe are what we're after, we can use our ideas from the first section and what we know about the sum of the angles being 180 degrees. If I know that this angle, for example, is a right angle, that means that angle is equal to 90 degrees. So if I have 90 degrees and 30 degrees, then my missing angle, angle 3, will be 180 degrees minus the 30 and minus the 90, which will tell me that that angle is going to be 60 degrees. Also, because angle 2 and this right angle are vertical angles, then that tells us that this angle is also 90 degrees. And so then we can find angle 1 by saying 180 minus 45 minus 90 for angle 2 is going to give us the measure of angle 1, which happens to also be 45 degrees. They may give you some combination of parallel lines or perpendicular lines, and you need to use what we learned last section with our vertical angles and alternate interior angles and those sorts of things. And you should have enough knowledge at this point to be able to find whatever missing pieces that they give you or that they ask you to find. When we classify triangles, there are several different kinds. There are three. Well, there's more than three. But three that have to do with the number of sides that are the same. If you have a triangle where none of the sides are equal, they all three have different lengths, we call that triangle scalene. If two of your sides are equal in length and the third one is different, that triangle is called isosceles. And if all three sides of your triangle are exactly the same, then we call that triangle an equilateral triangle. Also, if all of the angles inside your triangle are less than 90 degrees, we call that an acute triangle. If at least one of your angles, and this one isn't a lot bigger than 90, but if one of your angles is greater than 90 degrees, we call that an obtuse triangle. And if you have a triangle like we did on this other page where there's a 90-degree angle involved, we call that a right triangle. Two words, even though mine run together. So an acute triangle has all of the angles less than 90 degrees. Obtuse means there's one angle bigger than 90. There can't be more than two bigger than 90 degrees, but one of them is. If one of the angles is a 90-degree angle, we call it a right triangle. If you have two triangles and their sides are related by the same ratio, the ratio of the sides that are in the same place are the same, we call those triangles similar triangles. With similar triangles, and on this one we would have to be told that they're similar. Let's go ahead and just fill this one in. If we look at the ratio 4 divided by 8, that is exactly the same as the ratio of these two sides, which is 5/10. It's also the same as the ratio of these two sides. All of these ratios, if we clean them up, are equal to 1/2. If we have two triangles that are similar, I'm just going to sketch here because I'm running low on time. And if we're told that those triangles are similar, let's stick with right angles here. Okay, 6, 8, and 10. And let's say this side is 9. And I'm told that these triangles are similar. That means I want to figure out, that means the ratio of their corresponding sides is the same. And what I would like to do is figure out what x is and what y is. So I can take the pair of sides that I know. I know these two that correspond. And I'll say 6/9 has to be the same as the ratio of these two sides. So that has to be the same as 8/x. Now I know how to solve a proportion from one of my last chapters. And that says if I take the cross products, 6 times x has to be equal to the other diagonal, 72. And dividing both sides by 6 turns out that x is equal to 12. The length of this side is equal to 12. I can do the same thing to try to figure out what y is equal to. I can say 6/9, the two sides I knew initially, has to be the same as 10/y. If I multiply my cross products, I find out that 6y is equal to 90. Dividing both sides by 6 gives me y equal to 15. So similar triangles, knowing that triangles are similar, we can set up proportions to help us find the missing sides if we know only pieces but not all of the sides of the triangle. The last thing that's covered in this section, section 10.2, is Pythagorean theorem. Pythagorean theorem is something that most students can rattle off even if they have no idea what it relates to. What Pythagorean theorem tells us is the ratio of the sides of a right triangle. And we have to have a right angle in our triangle to be able to use this. But if we have a right triangle and the two sides that make the right angle we call A and B, then we find out that a squared plus b squared equals c squared. Now it doesn't matter which one is A and which one is B, but C has to be the hypotenuse, the one across from the 90-degree angle. So let's say that we know that A is equal to 4 and B is equal to 5. Then I can find C by saying 4 squared plus 5 squared has to be C squared. And then I can figure out what C is. So 16 plus 25 has to be C squared. So 41 is C squared. The only way we've talked about for solving a quadratic equation is to set it equal to 0 and factor it. Most of these aren't going to factor, so we're going to throw the square root in there. If c squared is 41, then c has to be the square root of 41. Now we're going to leave it in radical form. We're not going to change it to a decimal for right now. If, really quickly draw another one of these. Maybe of the sides we know, maybe we know that this side is 10 and that this side is 5 and that this is a right angle. What I'm missing now is my b, but I still have to set it up so that a squared plus b squared equals c squared. So now when I take 25 plus b squared equals 100, when I subtract 25 from both sides, I'll find out that b is equal to the square root of 75. Now we didn't talk about simplifying radicals in here, and I'm not going to go into the details of that right now, so I'm good with you just leaving it as the square root of 75. But this should be good enough to get you through to the end of section 10.2.